Hello, welcome to In 5 Minutes. We start with the characteristics of a common base configuration. In common base configuration, input we have emitter and output we have collector. So when we are dealing with the input characteristics, we have input voltage and input current. VI characteristics, voltage on the x-axis, current on the y-axis, and keeping the output voltage to be constant, we are plotting the graph. This is the standard method to draw the input characteristics. X-axis you have input voltage, y-axis you have input current, and while measuring this, what we are keeping constant is output voltage. When you look at the graph, VCB is the output voltage, VEB is the input voltage, and IE is the input current. The sign just indicates that we need to write it as VBE, or we can write it as plus IE. Because of the direction, we are writing it as negative. Now what you can see over here is the characteristics of the forward biased common base NPN transistor is similar to a diode. In diode characteristics also, after 0.7 volts you get an exponential increase in the current with the increase in the voltage. So what you can say, it is similar to a forward biased diode. Now when you look, as the VCB value increases, your current IE increases with the value of VCB. That means when you are increasing the reverse bias voltage, what happens? We have seen the early effect. What happens in early effect? If you increase the reverse bias, base width increases or decreases? Base width decreases. As the base width decreases, recombination in the base decreases. So what increases? Your emitter current and collector current increases. Hence, as you increase the reverse bias voltage, you will get more straight curve for the increase in the emitter current with the increase in the VCB. Right now, when you are increasing your input voltage, your output current is as shown in the graph, keeping your VCB to be constant. Now how to find the input resistance is just the slope of the graph. How we find slope? M equals to y2 minus y1 upon x2 minus x1. So change in the y parameters. On y axis you have I, E. So change in I upon change in VEB, keeping VCB constant, will give you the input resistance. Now at the input of the transistor you have a diode which is forward bias. So the input resistance value is very low. How much is the value? It is in the range of say 20 to 100 ohms. The value of the input resistance is very less. Now coming to the output characteristics. Now in the output characteristics, what you can see, there are three regions of operation. You have active region, you have saturation region, and cut off region. Now we'll see each region of operation in detail.